Hello everyone, this is Chaz. The general area of concern for my presentation is how dose responses for exercise volume, frequency, and intensity differ between trained, untrained, and athletic populations. So basically, how does trained status determine optimal dosages for each of these three training parameters? So what I want to accomplish with this presentation is I want to review the background on this issue of dose response relationships in exercise training in general. And then I want to review and report the findings of a meta-analysis searching for dose response relationships of balanced training in healthy adults. And this meta-analysis was conducted for the purpose of helping us understand how volume, intensity, and frequency influence effectiveness of balanced training in healthy adults with different training histories. As we heard in the presentation from Dr. Alvar, optimal dosages of exercise intensity, volume, and frequency for eliciting optimal training responses change depending on the training status of a person. And training status was categorized in three groups. We had untrained people, those are people that never engaged in resistance training. Trained people, those are people who engaged in resistance training for over a year at least. And athletes, and those were people who were involved in competitive sport on a college or university level. And the general understanding that you came away with was that as you become more trained, training dosage must increase in order to see further improvement. So what I would like to do now is look at some specific information that was shared about how optimal dosages for volume, intensity, and frequency increase or just simply change according to training status. As far as volume, volume was discussed and categorized in two subcategories, which was sets and number of exercises. Untrained persons, the review suggested that one set had a large effect size, simply meaning that it was highly effective for eliciting results in untrained populations. And the review also pointed out that the effectiveness of one set in untrained populations was equivalent to the effectiveness of four sets in trained populations and equivalent to the effectiveness of eight sets in athletic populations. So basically what we should understand from this is that each individual set is less and less effective for eliciting a response as one's training status increases, and therefore more sets are necessary for effectively achieving results. Optimal dosages for intensity was also reported. And intensity in the literature is typically expressed as a percentage of one's maximal performance or maximal capacity. And what we see is that as training status changes, so does the optimal intensity needed for eliciting results. In untrained populations, 60% is identified as being necessary for effectively achieving strength gains. In trained populations, it's 75% to 80%. In athlete populations, it's 85% plus. And so basically what we're seeing here is that as your level of training increases, the intensity needed to elicit a response increases as well. The review also reported dosages for frequency. And frequency in the literature is typically expressed as days per week per muscle group. Okay, and with training frequency, we kind of see an inverse relationship of dose and response. So lower dosages, when looking at frequency, appears to elicit more effective results and a more effective response. Okay, so in untrained populations, 3 days per week per muscle group was deemed to be optimal, while when we looked at trained and athletic populations, 2 days per week per muscle group appeared to be optimal. And a proposed explanation for this was that more trained populations are capable of imposing a level of stress on their bodies that takes longer period of time to recover from. And this often requires that the training frequency per week be reduced because the spacing in between training sessions is increased. So in short and in general, the current background on dose-response relationships of volume, exercise volume, intensity, frequency in persons with differing training statuses support the principle of progressive overload. And what progressive overload simply means is that low intensity, low volume becomes less effective as we progress in training development. Okay, and therefore, as your training status increases and your training level increases, we need an increased level of intensity and we need an increased level of volume. Now, the question you might have is, or we might have, is does current research into other types of training that have been imposed upon persons of differing training levels report dose responses that support this principle of progressive overload. So do we see the same type of dose response relationship in other relative to training status when using other types of training? So what I would like to do now is we're going to review an article looking into dose response relationships of balanced training in groups with differing training histories. So the title of the article being reviewed is Dose Response Relationships of Balanced Training in Healthy Young Adults, a Systematic Review and Meta-Analysis. This is a 2015 article. So this is the most recent article I was able to find. This was the first systematic review examining dose-response relationships of balanced training leading to improved balance in persons of differing training statuses. Okay, the approach to this meta-analysis was as follows. There were 596 articles that were identified that were training healthy adults with the purpose of improving balanced training. Only randomized controlled studies investigating balanced training were included, so the standards of experimentation were high because they used a randomized controlled method. 25 of these 596 met the inclusion criteria set by the investigators, and therefore they were included in this review. And as far as what the researchers or investigators sought to answer by doing this review was, how does volume, intensity, and frequency influence effectiveness of balanced training in young healthy adults with different training histories? So some characteristics of the study that were actually reviewed. Of the 25 studies, 3 looked into the effects of balanced training in elite athletes, 4 looked into sub-elite athletes, 9 looked into recreational athletes, and 2 looked into untrained subjects. Okay, and there were a total of 1,043 subjects across all 25 studies. Subjects were 16 to 40 years old, and the average length of the studies were 4 to 6 weeks. So I felt that there were some general outcomes and conclusions of this review that we should go over first before I go into specifics of the dose-response relationships for balanced training in young healthy adults with differing training histories. One is that there was a small number of studies for each category of training status, as you saw in my previous slide, and therefore a differentiated consideration of dose-response relationships was not feasible. So the dose response relationships reported are general, okay, but we should also keep in mind that this study also concluded that balanced training appeared to be most effective in elite level athletes. Okay, and I'm going to visit later on in the presentation why I think that's significant based on the kind of dose response relationships that were reported. Also, this report found that a broad range of balanced training modalities resulted in improvements. And so while this was found to be the case, the paper did report and suggest some optimal dosages of volume and frequency suggestions, and those were based on effect sizes that were calculated. Some limitations across these 25 studies. Only 7 were classified as high quality. Many of the studies also failed to report data that's necessary for computing effect size. For those of you that are not familiar with what effect size is, pretty much the p-value, it tells us whether or not there was a significant difference detected in the data collected. It's usually useful for comparing means. Is there a significant difference between the means? And effect size tells us how large a significance. So how great a significance was this detected significance? So we need both. Another thing is that no information regarding balanced training sequencing was provided in many of these studies. So we don't know if the balanced training came before or after a regular training session. So basically we can't take into consideration crossover effect when looking at this information. And lastly, this is a common limitation in many studies, the difficulty in separating the impact of the training modality that was used from that of other training modalities that probably were also imposed on the athlete. So how do we know the improvements detected and seen were due to balanced training and not to some other type of training? As far as frequency, the range of frequency throughout the 25 studies was 2 to 7. The mean frequency was 3 times per week. Okay. Now, one study reported that 6 sessions was deemed most effective because the effect size was 1.84. Okay, the second highest effect size was found for 3 sessions per week. Okay, and that was when they looked at 3 sessions per week compared to 2 or 4, and therefore 3 sessions were deemed to be most effective based on the effect size calculated. Okay, so next we'll discuss what the review had to say about volume. Okay, the range of exercises used in these studies was anywhere between 1 to 10. The number of sets per exercise was anywhere between 1 to 7. The mean number of exercises was 4. The mean number of sets per exercise was 3. And the review also concluded and reported that a broad range in the number of exercises and number of sets done per exercise elicited significant results when doing balance training. However, through an analysis, it was able to determine that 4 exercises appeared to be the most effective, and that 2 sets per exercise appeared to be most effective. Now, this is interesting to note because that leaves you with 8 sets, so 2 by 4, working on the same type of training outcome, which is balance training. Now, this is significant because the review also said that when reviewing the studies, balance training appeared to be most effective in the elite athlete population. Okay, and if you remember from the review that we went over a little while ago, 8 sets is proposed as being effective for eliciting results in elite level athletes. So I'm sure we can see the connection there. Here it is. This review is saying that 4 exercises are most effective for balance training, 2 sets per exercise. It leaves us with 8 sets, but it just so happened that the same review also says that balance training appears to be most effective in elite level athletes. Okay, so next we will talk about intensity. All right. Well, we know that the principle of overload says that to induce a training effect, exercises must be performed at or near a person's capacity. Okay, now balance training protocols in the literature typically don't refer to intensity of balance exercises relative to individuals' capacity. Okay, and they don't do that because there really isn't an established way of doing that, as you might imagine. I'm pretty sure if you just think about it in your head, you'd say, yeah, well, how would you determine intensity of a balance exercise, relative to your maximal, balance ability? So this review naturally was unable to uncover any info on the influence of intensity on the effectiveness of balance training in these different training groups. So to wrap this up, let's talk about what this review has done and what information we've learned, and also I'll add a little bit more on. What this review has done is looked at what the research has to say about the dose-response relationships of balance training in healthy adults with different training histories. We found that balance training was determined to be an effective means for improving balance in young healthy adults. They also determined that balance training was most effective in elite populations. Okay, and one reason proposed for this by the investigators was that elite level athletes have accumulated thousands of hours of deliberate balance practice over their lifetime, and that this practice helps them to acquire motor tasks more efficiently with greater precision. So basically what they're saying is that the more balance training you've been exposed to, that's going to improve the quality and the results of future balance training interventions. And this almost appears to contradict the principles of progressive overload because that's based on the notion that the more training you have, the less responsive you are to future training interventions. But in this case, it appears that the more balance training you have, the more responsive you'll be to future balance training interventions. So that's the opposite of what occurs with strength training. Also, this review uncovered that there's a broad range of effective balance training modalities. Another thing we identified is that currently there are not enough studies looking into each training status category to make differentiated considerations of dose-response relationships of balance training. So we don't know what optimal dosages of frequency, volume, and intensity of balance training are for a specific training status. We just have these general dosages that they've given us, and that these general dosages appear to apply mostly to elite populations. The dosages considered most effective were as follow. Frequency, 6 times per week, was deemed most effective. For volume, it was 4 exercises and 2 sets per exercise. Again, the significance of that was that that's a total of 8 sets, okay, leaving you, which again is a protocol deemed necessary for eliciting results in athletic populations. And as far as intensity, we were unable to determine that because there really isn't an established way of determining intensity for balance training. All right, everyone. Well, I hope you enjoyed my presentation. I hope it was informative, and thank you for listening. And I hope you all have a great week.